All right, guys, so for part two of our review, I'm going to continue off on lesson 5.3 with adding and subtracting with unlike denominators, and specifically doing some examples where we're going to need to borrow. So the first example we're going to do is 1 4/5 plus -5 and 5/7. So when I look at this expression, I notice that these fractions have different denominators. So that means their piece sizes are different. So I'm going to need to find a common denominator. So there's two different ways I can solve this problem. The first way is I can change both of these fractions to improper fractions and then solve. And then the second way is I can keep them as mixed numbers. It's whatever way that you prefer. I like to keep them as mixed numbers, but you can do either way. So I'm going to start with the first way, which is changing them to improper fractions. So first, before I find a common denominator, I'm just going to find out what these are as improper fractions. So 1 4/5, I do 5 times 1, which is 5, and then I add 4 to get 9. My denominator stays the same, so this will be 9/5. Then I change -5 and 5/7 to an improper fraction. I ignore my negative and do 7 times 5, which is 35, plus 5 is 39/7, and then I add back my negative. So now I have 9/5 plus -39/7. So now I need to find a common denominator. So I think about 7 and 5, what is a common multiple they share? And I'm going to use 35. So now I need to scale up both of these improper fractions to have a denominator of 35 so that I can then add my numerators. So when I go from 5 to 35, I multiply by 7. So I do the same in my numerator. 9 times 7 is 63. Then I do the same with my second fraction. 7 times 5 gives me 35. So then I need to do 39 times 5, which is 195. Negative 195. Hopefully that's right. That's right. So now that they have the same denominator, that means the piece sizes are the same. So now I can add them. So 63 over 35 plus negative 195 over 35. So now since I'm adding and one is negative and one is positive, I'm actually going to need to subtract them, right? So that means that I need to subtract 195 minus 63. 5 minus 3 is 2. 9 minus 6 is 3. So I get 132. And I need to remember to add my negative because this fraction is greater than this fraction, so there's more negatives than positives. And then I keep my 35. Now I could write that as improper, or I could keep it like this. So then I think, is it simplified? Well, 35 has factors of 5 and 7. 132 will not have factors of 5 or 7. So that is simplified. So let's think about the second strategy where I keep them as mixed numbers. So again, I already found a common denominator of 35, so I'm going to use that with my fractions here. So 1 4/5, if I scale 4/5 up to have a denominator of 35, I'm going to multiply by 7. So 4 times 7 is 28. So I have 1 28/35. For -5 and 5/7, sorry, that's the bell, I keep my -5. 7 times 5 gives me 35, so I do the same up top. 5 times 5 will give me 25. So now I have 1 28/35 plus a -5 25/35. So again, since I'm adding and one is positive and one is negative, I need to subtract them. So I'm going to put the bigger number up top, so that will be 5 25/35 minus 1 28/35. Now when I look at this here, I cannot take away 28/35 from 25/35. It's kind of like if I had this example here, 123 minus 99. I can't take away 9 from 3, so I have to borrow from my previous number. And when I borrow 1 from 2, I now add a 1 to 13. So now I can subtract and get 4. Same here, I can't do 1 minus 9, so I need to borrow 1 from my previous number and add 1 here. So 11 minus 9 will give me 2. I got to do the same thing here. I can't take away 28 from 25 because I'm going to get a negative number. So that means I need to borrow 1 from my whole number. So when I borrow 1 from my whole number, I now need to add 1 to this fraction. So if I think about adding 1, so I'm going to do that over here, 25/35 plus 1, to be able to add these, I have to have a common denominator. So if I want to find a common denominator, well, 35 can be their common denominator. So I can think about 1 as 35 over 35. So then I can do 25/35 plus 35/35. So since the denominator is the same, I can add the numerators. 25 plus 35 will give me 60. So now this fraction is 60 over 35. That was helpful because now I can take away 28 from 60. 60 minus 28 will give me 32/35. 4 minus 1 will give me 3. Now I just need to remember to add back my negative because there are more negatives than positives. This mixed number will be the same as this improper fraction. So it's whatever way works for you. So that is my first example. I'm going to do one other example on the back. I'm actually going to write this example here. And then I want you to do it on your own, and then I'm just going to put up the answer. So the next one is going to be -10 6/7 plus 5 8/9. So I want you to work on this one on your own. So pause your video now. All right, so what I did is I put up the answer key with these two different strategies. The first strategy is if you kept it as a mixed number. The second is if you change them to improper. So both of these fractions are going to be the same. So you can pause your video now if you want to take a look and check and make sure you're on the right track. So lastly, today in class, or tomorrow, depending on when you have math, we did lesson 5.4, which was multiplying fractions. So multiplying fractions was nice because you did not need a common denominator, right? So for example, if we have 2/3 times 15/8, 2/3 times 15/8. When we're multiplying fractions, we can think about this as 2/3 of 15/8 or 2/3 groups of 15/8. So the way that we multiply with fractions is we multiply the numerators and the denominators. So if I do 2 times 15, I will get 30. 3 times 8 will give me 24. 30/24 is not simplified because they're both even. So I know that I can scale down by 2. So 30 divided by 2 is 15. 24 divided by 2 is 12. 15 and 12 still have a common factor of 3. So 15 divided by 3 will be 5. 12 divided by 3 is 4. So I can write my answer as 5/4 or 1 1/4. Either way works. Now, if you wanted to pause here and cross simplify, I could cross out my 3 and my 15 because they have a factor of 3 in common. And I can cross out my 2 and my 8 because they have a factor of 2 in common. So 2/8 would become 1/4. 15/3 would become 5/1. Then I would get 5/4, which is my simplified answer. Now we can also multiply mixed numbers. So for example, 3 1/2 times -5 6/8. If I want to multiply these mixed numbers, I need to change them to improper fractions. I can't just multiply the whole numbers and the fractions together because I'll be missing part of the answer. So 3 1/2, changing that to an improper. 2 times 3 is 6. 6 plus 1 is 7. So this will be 7/2. -5 6/8. 8 times 5 is 40. I ignore that negative. 40 plus 6 is 46/8. And then I add back my negative. So now I have 7/2 times -46/8. I can pause here and see if there's anything that I can cross simplify. If I don't want to cross simplify, I can simply just do 2 times 8, which is 16. And then -46 times 7, which is -322. And then I can simplify from here. Or I could see that 2 and -46 have a common factor of 2. So -46/2 will become negative 23 over 1. So then I can do 23 times 7, negative 23 times 7, which is negative 161 over 8. And then I think that is going to be simplified. You could write it as a mixed number if you want as well. So just keep in mind that you can cross simplify, or you can just simplify at the end. If I would have gotten this answer, I would have just needed to divide both by 2 because they're both even. So that is our second example. Something else that we did is we did some examples with variables. So for example, x to the power of 2, 3x to the power of 2 over 5 times 15x over 2x. So if I have this example, I have two fractions. Since I am multiplying, I don't have to worry about finding a common denominator. So I can simply multiply my numerators. So 3x squared times 15x over, multiply my denominators, 5 times 2x. And then I pause and think about my numerator. So in my numerator, is there anything that I can combine or simplify? Well, if I think about 3x squared, that's going to be the same as 3 times x times x. And then I'm multiplying that by 15x, which is really 15 times x. So if I think about what I have in my numerator, I have x 3 times, and then I have a 3 and a 15. So since I am doing x times x times x, that will equal x to the power of 3. 3 times 15 will give me 45. Now in my denominator, I have 5 times 2x, which really means I have 5 times 2 times x. So that means that I can do 5 times 2, which is 10, and then I have my x. So then, once I combine my numerators and denominators, now I see if there's anything else I can do to simplify. So if we think about the variables, I have 3 x's in my numerator and an x in the denominator, which means I can cancel out one of those x's in the numerator with one of the x's in the denominator, because x over x equals 1. So those will cancel out, and I'll be left with x to the power of 2 in the numerator. Then if I think about 45 and 10, those are going to have a common factor of 5. So if I divide both by 5, I will get 9 over 2. So that 9 will be up in my numerator, and then my 2 will be down in my denominator. And again, keep in mind that when we're multiplying, sometimes we'll have negatives, so keep in mind your integer rules when you're multiplying. So a negative times a negative will equal a positive, and negative times a positive will equal a negative, and a positive times a negative will equal a negative. All right, guys, good luck studying.